Hi, welcome to Math of Chem. My name is Dr. English. Today we're going to be talking about molecular formulas. Specifically, we're going to look at what is a molecular formula, determining molecular formulas, and then finally some worked examples at the end. What is a molecular formula? A molecular formula is going to give the actual number of atoms of each element in a compound. These are always a whole number multiple of the empirical. So how do you find a molecular formula? The first thing that you need to do is calculate the mass of its empirical formula. If the empirical formula is given to you, divide the empirical formula mass into the known molecular formula mass that does need to be given to you, and the resulting number is what you need to multiply the subscripts in the empirical formula by in order to get the proper molecular formula. And we are going to do a number of worked examples with this. Determining the molecular formula. Let's say our example is glucose, and we know that the empirical formula of glucose is CH2O. This is given to us. What is also given to us is the molecular formula mass of glucose, which is 180 grams per mole. So technically we would be given this, the empirical formula, and the molar mass, otherwise known as the molecular mass, because we are dealing with a molecule. What we would need to calculate is the empirical formula mass, which is 30 grams per mole. And you might say to yourself, well, how do I know that the empirical formula mass is 30 grams? Well, if we take one carbon, which we know has an atomic mass of 12, and hydrogen, we have two of those with an atomic mass of 1, that gives me 2, and a single oxygen with an atomic mass of 16, and that's 16 right here, and we add those up, we get 30 grams per 1 mole, which is listed right here. Now, we have the molar mass, we have the empirical formula mass, so we need a whole number. So we're going to take the larger amount, which is the molar mass, and divide that by the empirical formula mass, which was given in this example, but typically we would have to calculate, and we get the number 6. That 6 right there is what you are going to multiply all the subscripts by in the empirical formula. So the molar mass of glucose is 6 times greater than its empirical formula mass. So take that 6, multiply it by all the subscripts in the empirical formula, and you will get the molecular formula of glucose, which we know is C6H12O6. The first example that we're going to do is a hardcore example, and this is definitely for my students, where you need to find the empirical formula first and then the molecular formula. A compound is used as an additive for gasoline to help prevent engine knock. Shows the following composition: 24.27 grams of carbon, 4.08 grams of hydrogen, and 71.65 grams of chlorine. The molar mass is known to be 98.6 grams. Determine the empirical formula first and then the molecular formula of this compound. So the first thing that we're going to do is convert each of these values into moles. So 24.27 grams of carbon, 4.08 grams of hydrogen, and 71.65 grams of chlorine. Multiplication sign in a line, 12 grams of carbon per 1 mole of carbon. Set the rest of these up, 1 mole of hydrogen per every 1 gram of hydrogen, and then 1 mole of chlorine for every 35 roughly grams of chlorine. Okay, so for the first one, 24.27 grams of carbon times 1 divided by 12 is 2.02 moles of carbon. For the next one, for hydrogen, 4.08 times 1 divided by 1 will of course be 4.08 moles of hydrogen. And finally, 71.65 grams of chlorine times 1 divided by 35 will be 2.04 moles of chlorine. Then I need to look at all of my numbers and say, okay, which one is the smallest number of moles? And it turns out it's carbon. So I'm going to divide each one of these by 2.02 2.02, 2.02. That turns out to be 1. This turns out to be 2. And this turns out to be 1. So the empirical formula here is going to be C1H2Cl1. All right, that's my empirical formula. I did the first part. So what's the next step? The next step is to find the empirical formula mass. So we have a carbon, so 1 carbon times 12, that's 12. Hydrogen, we have 2 of those, times 1, that's 2. Chlorine, we have 1 of those, times 35, that's going to be 35. And if I add those all together, I get 49 grams per mole. The next step is to say, hey, they gave us a molar mass here, and that molar mass is 98.6 grams per 1 mole. Now I'm going to take that and I'm going to divide that by 49 grams per mole, which is my empirical formula mass. And when I do that, the answer will be 2. So what does that mean? That means we need to take our empirical formula, C1H2Cl1, and multiply all of those subscripts by the 2 right here. And finally, our molecular formula will be C2H4, that's a 4, Cl2. So we found 2 things here. We found the empirical formula and we found the molecular formula. Now let's do an example that just focuses on finding the molecular formula. A compound has a molar mass of 90 grams per mole and the empirical formula CH2O. What is the molecular formula? Okay, step 1, we have CH2O. We're going to find the mass of this. So carbon, 1 carbon times 12, that's 12. Hydrogen, we have 2 of those times atomic number of 1, that's 2. Oxygen, we have 1 of those times 16, that's 16. And if we add all those up, we get 30 grams per mole. Then what we're going to do is take our molar mass of 90 grams per mole that was given to us and divide that by 30 grams per mole. And when we work that out, we get the number 3. So our empirical formula was C1H2O1. The ones are assumed. We're going to multiply all of those subscripts by 3. And our molecular formula now is going to be C3H6O3. And that's an example of how to find the molecular formula when given the empirical formula and the molar mass of the molecular formula. Let's look at another example. A substance has the empirical formula of CH2 and a molar mass of 56 grams per mole. Determine the molecular formula for this compound. Okay, CH2. So carbon, we have 1, 12, 12. Hydrogen, we have 2 of them, times 1, that's 2. We're going to add that up. 14 grams per mole is our empirical formula mass. We are given 56.0 grams per mole for our molar mass. We're going to divide that by 14 grams per mole. And when we divide this out, 56 divided by 14 is 4. So our empirical formula that's given to us is C1H2. We're going to multiply those subscripts by 4. So our molecular formula is going to be C4H8. And that is another example of how to find the molecular formula when given the empirical formula and the molar mass. So what did you learn? We talked about what is a molecular formula, and then we worked on determining the molecular formulas, and then finally did some worked examples at the end. Need more help? Feel free to contact me. Have a great day.